Welcome to another science video. All right, who's ready to kick this off? We are going to talk about formation reactions today. Now, a formation reaction is a reaction where one element reacts with another element to make a compound. So you can think of it as taking two simple things and making a more complicated thing. Now, we hopefully should be able to spot a formation reaction from a mile away because formation reactions always involve two or more elements joining together to become a compound. Now, the next few videos that we're going to be doing, the next few videos are going to involve predicting chemical reactions. So I'm going to give you what we're starting with, and you're going to have to tell me what we finish with, and you're going to have to make a completely full balanced chemical reaction. It's going to be pretty tough at first, but just stick with it. Stick with me, trust me, and let me know if you have any questions in the Google Doc. Let me know if you have any questions during the office hours, and we can figure this out together. We're good to go. Don't even worry about it. Okay, something to keep in the back of your mind is when predicting a chemical reaction, it's often useful to write out the word equation before we start writing the chemical equation. So here, what a word equation is just you writing using English words what is going to happen. So let's write our word equation. Solid lead can react with oxygen in the air. So, okay, all right. So we're going to get lead reacting with oxygen. Oh, that looks terrible. Oh, I'm getting used to writing down on something else right now. So lead plus oxygen is going to give us what? Okay, well, lead and oxygen put together is going to be lead oxide. So lead and oxygen is going to make lead oxide, but lead oxide is an ionic compound. So when we make lead oxide, we have to figure out what lead are we going to make. So I'm just going to put in lead oxide. Okay, and we don't know what lead we're going to make. So let's bring up our data booklet and let's take a look at the periodic table and let's look at what lead is. And so when we look at lead here, it sure seems to me like, well, we could use lead 2 or we could use lead 4, but we're going to use lead 2 because it's the more common ion charge. We're going to use the one that's on top. If it doesn't say what it is, we'll assume we'll make the more common ion charge. So lead 2. Okay, no problem. So let's go ahead and make lead 2. So lead 2 oxide. Perfect. So now we have our word equation. So we've got our word equation, and we should be able to turn this word equation. Now that we've got our word equation, we should be able to turn this word equation into an honest-to-goodness chemical reaction. So let's kind of go down a little bit more, and let's write our chemical reaction. Now, you've done this before. You've turned words into chemicals before. What is lead? Lead is Pb, solid. What is oxygen? Oxygen is O2 gas, right? These are elements, so we think to ourselves Hofbrinkel. Well, lead's not in Hofbrinkel, but oxygen is, so it's O2 gas. Okay, sure, no problem. We're going to make lead 2 oxide. Lead 2 oxide is an ionic compound. It's made out of lead 2 and oxide. Well, think to yourself, if it's an ionic compound, let's look at the ions. The ions, one ion is 2 plus, one ion is 2 minus. So if I've got a 2 plus and a 2 minus ion, how many of each do I need? Well, you only need one of each, PbO. And because it's an ionic compound and there's no water around, it's not an aqueous solution. Nothing in here is aqueous. we're going to assume it's going to be made as a solid. Okay, perfect. So we've made some assumptions about what we're going to make. I'm just going to erase this right now. So lead reacts with oxygen to make lead 2 oxide. Perfect. This is awesome. So now let's go ahead and balance it. We need to balance our chemical reactions when we're when we're going through this process. What's the most complicated thing here? Lead oxide, and specifically the oxygens are more complicated than the lead. So 2 oxygens. So, okay, I'm going to need 2 oxygens on the other side. I'll put a 2 in front. 2 oxygens, 2 oxygens. Now there's 2 leads. So what do I have to do over here? I got to put in 2 leads. Do you see how that worked? We went from just writing out the chemical formula, or writing out the names of both of these things, to predicting what was going to be made. A metal and a nonmetal are going to make an ionic compound. That's what we're doing. We're writing just 2 elements adding up to make a compound. Okay, let's try another one. Let's try another one here. So we're going to go down. We're going to try this second example. Magnesium oxide is formed from its elements. Okay, so what did we say? We wanted to try the word equation first. So if we're making magnesium oxide, what 2 elements do you think? Just pause the video for a second. You don't actually have to pause it, but whatever. Pause the video for a second, or pause your brain for a second, and think, okay, magnesium oxide. What 2 elements do I have to make, or do I have to use to make magnesium oxide? Well, probably magnesium and not oxide, oxygen, right? Magnesium and oxygen is going to make magnesium oxide. Sure, no problem. Let's try that. Let's turn the word equations that we've written here into chemical equations. Magnesium. How do you write magnesium as a chemical? Well, Mg, and because it's solid at room temperature, solid. Oxygen. Well, Hofbrinkel O2 gas. And it's going to make magnesium oxide. Magnesium is 2+, oxide is 2-. You would check your data booklet if you didn't already know that. And we totally could right now if we wanted to, right? Look at that. Oxide is 2-. And if we look at magnesium, magnesium is 2+. Sure, no problem. Magnesium plus oxygen gives me magnesium oxide. Perfect. Okay, same thing as it was before. Let's balance this using the most complicated element, which is oxygen. 2 O's, 2 O's, 2 Mg's, 2 Mg's. And here we've got our balanced chemical reaction. So hopefully that wasn't too bad. What we're going to do, we're going to do a third example right now. And so, again, we're just going to follow the steps that we've been following so far. Iron 3 chloride is formed from its elements. So let's make iron 3 chloride. So we're going to make iron 3 chloride. Well, which 2 elements do you need to make iron 3 chloride? You need to make or use up iron, and not chloride, but chlorine. So let's go from names to formulas. Remember how important we said this was earlier, going from names to formulas? What is the formula for iron? It's an element. It's not in Hofbrinkel, so it's just Fe and solid. We'll look at the periodic table, and yes, it is a solid at room temperature. Let's take a look at it. Let's look at Fe. Fe has a white background in here, and that white background means it's solid as an element. Okay, perfect. Chlorine plus Cl2, and we'll look for its state of matter. Okay. Chlorine is shaded in gray, and that was a gas at room temperature. gas. So iron and chlorine make iron 3 chloride. Iron 3 is Fe3 plus. Chloride is Cl minus. So we need 1 Fe and 3 Cls. And because it's an ionic compound and there is no water around, if it's not an aqueous solution, then it's going to be a solid. Okay, we're not trying to dissolve it in water. So iron, chlorine makes iron 3 chloride. Now let's balance this. What's the more complicated element, iron or chlorine? Well, hopefully you can see that it's chlorine. There's 2 of them here and 3 of them here. How can I make groups of 2 and groups of 3 be the same? Well, if I have 3 groups of 2 and 2 groups of 3, then we have 6 chlorines on each side and 2 irons over there. That is my balanced chemical reaction. Hopefully you can see how this is kind of progressing. Hopefully you can see how we're able to do this. So what I'd like you to do is go through the rest of the notes. We're going to do a couple more examples, but go through the rest of the notes and try and make sure, try and see how successful you are. Check your answers against the key. You know, write everything down on line paper or in a booklet or something like that, but try it out first and then check your answers against the key. On the next page, I've got some balancing reactions. So I just try them out again, check them against the key, right? So we've got some balancing chemical reactions here. And then on the next page as well, there are some formation reactions. And I would like you to try these out, please. So look at the notes and try and copy them down onto a sheet of lined paper or something and try and finish them. We're going to do a couple of these, and then we're going to do 1 or 2 of these, and then I want you to try them out for yourself. Okay? So let's go ahead and try out a couple of these. So it says predict the product and balance the equations. Okay, no problem. So we've got aluminum reacting with bromine. Now, aluminum's a metal, bromine's a non-metal. We're going to make an ionic equation. We're going to make an ionic compound. So what are we going to make? We're going to make aluminum bromide or aluminium bromide. Well, aluminium bromide is Al3 plus and Br minus. Those are the ions that make aluminium bromide or aluminum bromide. So let's make a new compound, AlBr3 solid. So now all we have to do, we predicted what we're going to make. Now we just have to balance this chemical reaction. So, okay, let's go ahead and balance it. I've got either aluminums or bromines. Bromines are more complicated. 2 bromines on the left, 3 on the right. The lowest common multiple between 2 and 3 is 6, so I'll put a 3 here, a 2 here, and because there's now 2 aluminums, I'll put a 2 here. Perfect. No problem, right? So that's us predicting the product. We're taking that and we're predicting the product. Now let's do one more. You have hydrogen plus oxygen. Well, this isn't gonna make an ionic compound. Hydrogen oxide isn't really a thing. But what famous chemical do you know has hydrogen and oxygen in it? I bet you know one. I bet you know exactly which chemical we're going to be making. Hydrogen and oxygen, they can combine to make water. So now let's balance this chemical reaction. 2 hydrogens over here, 2 hydrogens over here. Don't have to do anything yet. 2 oxygens over here now. But because I put a 2 here, I've changed the number of hydrogens, so there should be 2 over here as well. Hopefully that was okay. I'm going to leave the other 3 for you to do, and we're going to go down to the bottom and we're going to do we're going to do one more chemical reaction here. We're going to try one more chemical reaction. So aluminium metal reacts with phosphorus, and it's going to make, what do you think? Aluminum is a metal, phosphorus is a nonmetal. It's going to make aluminium phosphide, right? It's going to make aluminum phosphide. So aluminium phosphide. That's what we're going to make. So let's try and do this chemical reaction. What's the formula for aluminum? Al solid. And you know it's solid because when you look at here, aluminum is white. And remember, white means that it's a solid as an element. Sure, no problem. It's going to react with phosphorus. Well, phosphorus is an element. Hofbrinkel, it's not in Hofbrinkel, but what is it in? It's in P4S8. Who do we appreciate? Hofbrinkel, yeah, whatever, it's fine. So don't worry about it. So phosphorus, right? Phosphorus is down here. It's also white, so it's a solid at room temperature. Also remember, all the polyatomic elements are here. Phosphorus is P4. Okay, no problem. And it's going to make aluminium phosphide. Aluminium is Al3+. Phosphide is P3-. We need one of those and one of those to make AlP solid. I know that looks weird, but that is the formula that we're going to be making. So aluminum reacts with phosphorus to make aluminium phosphide. And now we just have to balance this. And balancing it is going to be pretty straightforward. Aluminums, I'll leave till the end. 4 phosphoruses, 4 phosphoruses, 4 aluminums, 4 aluminums. That's all you got to do. I'll try one more reaction, then I'm going to let you do the other ones by yourself. So let's take lithium metal reacts with phosphorus. And what do you think this is going to make? A metal plus a non-metal makes an ionic compound. Lithium phosphide. Lithium is +1. Phosphide is P3-. So let's try and make this. Lithium metal, the formula for that is Li solid. Reacts with phosphorus. Whoops. Reacts with phosphorus. To make lithium phosphide. How many lithium ions and how many phosphide ions do I need in order to make a balanced or a neutral compound? You probably need 3 lithiums and 1 phosphide. Okay. Well, which one of these is more complicated? 3 lithiums and 3 lithiums, 4 phosphoruses and 4 phosphoruses? I don't know, man. Let's go with the 4. 4 phosphoruses, 4 phosphoruses. 4 times 3 is 12 lithiums, so 12 lithiums. Perfect. This is a perfectly balanced chemical reaction. So what I want you to do is I want you to try the rest of these notes, okay? So go through and balance these reactions, balance these, test your balancing. But that's kind of old news. This is just how to balance a formation reaction. This page is where it gets super serious. You have to predict what's going to be made. Metal, non-metal, ionic compound. Okay? You have to predict what's going to be made, and then you have to balance it. That's tough. Check the key if you have any questions. Let me know in the Google Doc if you have any questions. Come talk to me in the office hours, whatever, okay? Just try it out, and let's see if we can get this, and we're going to get better and better and better at this as time goes on, okay? Try the rest of the questions on those 2 sheets, and let me know. Thanks. See you later.